right, guys. Hope you all had a fantastic weekend. Today we're going to hit the ground running. And last week when y'all were in here, I showed you what pH meant, like what pH scales meant. Remember, an acid goes from, an acid goes from 0 to 6.9 on the pH scale. And what does the base go to? You're right. It goes to from 7.1 to 14 on the pH scale. Because neutral is going to be 7. And so acids, they give up hydrogens to make the hydronium ions. And then bases give up OH ions. And so if I talk about pH, I want to be able to calculate what the pH is going to be based off of your concentration, like your molarity. And so there's a couple of equations that are really, really simple that I want you to write down. And basically, if I know my concentration, I can say pH is equal to negative log of my hydrogen concentration. Because if I'm talking about H, like your pH, I can only solve for your hydrogen concentration. Now, so that's good if I'm talking about an acid, because acids give up hydrogens, but bases don't. Bases give up OHs, which are hydroxides. So if I have a base, I have to use another equation that says pH is equal to negative log of your hydroxide concentration. Now, don't get all worked up whenever I talk about log. It is really simple. It is just this little button right here. Just the log. So I say negative log, and then I put in what my molarity is going to be. So let's work some actual problems. And I'll show you this really is something very simple. All right, so let's start off with this one right here. Question number 2 on your paper. Now this is board work. So as soon as you get this paper, make sure that you write it down on your table of contents. It's already written on the page on my table of contents that I have going on the wall. I have it as slot number 15 over there, pH calculations board work. All right, so make sure you write board work across the top. Do not turn this paper in. Okay, so if I have nitric acid is HNO3. So if this right here is my concentration and it's nitric acid, guys, look, for every one of the HNO3 compounds, I have one hydrogen. So if this is my concentration of this compound, that's also going to be the same concentration for my hydrogen. If I had something like number 10, where it says sulfuric acid, that is H2SO4. That means for every one compound, I have 2 hydrogens. And so my hydrogen concentration that I would plug into this equation right here, I would have to take the concentration and I would multiply it by 2 because there's 2 hydrogens for every one compound. But let's do this one first. Since it's just one hydrogen for this compound, I can say this concentration is the same as my hydrogen concentration. So I can say pH is equal to negative log of 6.6 e to the negative 6. So with my calculator, I'm going to type in, let me move it to where you can see. I can type in negative log, negative log 6.6 second comma negative 6. And it tells me that this right here would be my pH value. And if this is an acid, that makes sense because it's less than 7. And so my pH is 5.18. Now, in order to figure out the pOH, there's one more little equation that I want to show you, and it's pH plus pOH is equal to 14. So this is what makes something an acid. This is what makes something a base. And so if I know my pH is 5.18, if I want to solve for my pOH, I just subtract it from 14. So I say 14 minus 5.18, and my pOH is 8.82. All right. Now let's do this one for sulfuric acid. So I told y'all a while ago, since there's 2 hydrogens for every compound, I would need to take this concentration and multiply it by 2. So 0.000896, and I'm going to multiply it by 2 because that tells me I've got twice as many hydrogens for every one compound. So 0.000896 times 2 gives me a concentration of 0.001792. So that's how many hydrogens I would have floating around in my beaker whenever I put this in. And whenever I put it into water, it's going to break apart into the cation ions versus the anion ions. So that's how many of those hydrogens you have floating around. So to find the pH, I say negative log of this hydrogen concentration, so 0.001792. So negative log 0.001792, and it tells me my pH is, because this is hydrogens that I'm talking about, so I'm solving for my pH, 2.75. Now if I want to solve for my pOH, then just subtract it from 14. So 14 minus 2.75 is 11.25. Okay, and if I wanted to do this, look, it gives me grams and it gives me volume. And so I need concentration, molarity. And so to do this one, you would have to solve for your molarity first by changing grams to moles and then dividing it by my liters to solve for my molarity. And then once you have that, then I can figure out the pH of this. So once you know that concentration, once I figure out that molarity, I would multiply it by 2 because there's 2 hydrogens in this compound. And then I can just do negative log. I can just do negative log of that hydrogen concentration. Would tell me my pH. But let's say I'm doing something like, a base, NaOH. So this is NaOH. It doesn't just have hydrogens floating around. It has hydroxides. And so I can do negative log of my hydroxide concentration. Look, for every 1 sodium hydroxide, I only have 1 OH. And so that means that is the concentration of my OH. So since I'm solving for OH, I've got to do pOH is equal to negative log of 0.000469. So negative log 0.000469, and my pOH value is a 3.33. Now, we always base everything off of pH. Even though I had to solve for OH, we still base everything off of pH. That way I can compare acids versus the bases. So I still want to find my pH value right here. So I subtract that from 14. So 14 minus 3.33 is 10.67. Does that make sense that that would be a base? Well, yes, it does, because it is above the value of 7. Let's do this one, aluminum hydroxide. So aluminum is in group 13, so it has a +3 charge. OH has a -1 charge, and so whenever I crisscross it, it is AlOH3. That means for every 1 compound, I've got 3 hydrogens. So I want to multiply this number right here by 3 to figure out how many hydroxides you have. So 2.23 e to the -2 times 3. Sorry, I put that in wrong. So 2.23 e to the -2 times 3. So it's 0.0669 is my hydroxide concentration. So I say pOH is equal to negative log of this, because this is a base, so I'm solving for your pOH. So negative log of this number would give me, against my pOH, so 1.175. Subtract that from 14, and it's 12.83. And that makes sense because it's a base, so my pH should be above a 7. So use that as a way to double check yourself. Okay, I am not going to do the rest of these with y'all right here. However, this is what your worksheet's going to be over today. You have a worksheet and you have a lab. And so if I know the concentrations, I can calculate what the pH value is going to be. But in your lab, you're going to be figuring out your pH. And so once you know pH, I can go back and solve for, okay, what's my hydrogen concentration? What's my hydroxide? And so if I look right here on my calculator, the opposite, they were really, really cool whenever they made calculators. The opposite of log is this 10 to the X button. And so that's what you're going to use. If they give me pH, I'm going to put 10 to the negative pH, and that will tell me my hydrogen concentration. And I can do 10 to the negative pOH, and that will tell me my hydroxide concentration. All right, so this is what you're doing in today's lab. So your worksheet's going to have both ways. I might go from concentration to pH, and then on another part of it, I might go from pH back to concentration. And so you're just doing log, and then the opposite of log, which is 10 to the X. So in this particular case, my pH is equal to 2.5. That means my pOH is equal to 11.5. All right, so with my calculator, I'm going to say 10 to the negative 2.5, and that would tell me my hydrogen value. And then I'll say 10 to the negative 11.5, and that would give me my hydroxide value. So I'm going to come over here, and I'm going to hit second log to get the 10 up on the screen right here. And I'm going to put negative 2.5. And it tells me my hydrogen concentration is 0.00316 molar. So that's a really weak molarity. And this is an acid, so really that's the concentration I would be worried about. I'm going to go ahead and do the pOH. So I say second log to get the 10 to the X up on my screen. And I say negative 11.5. And this would give me 3.16 e to the negative 12. Now look at the amounts right here. This would be the same thing as 3.16 e to the negative 2. Whichever one of these gives you the highest value, it tells you what you have more of. And look, this makes sense. If this is an acid, I should have more hydrogens than hydroxides. Let's do another one. So 14 minus 11.3 is 2.7. So my pH right here is 2.7. So I say 10 to the negative 11.3 and 10 to the negative 2.7. So 10 to the negative 11.3. Okay, so that is my pH value. So that's my hydrogen concentration. This would be 5.012 e to the negative 12 molar. And this was molar. All right, so now let's do it for this one. Second log, negative 2.7, and it is 0.001995 molar. So this would be like 1.995 e to the negative 2. So I have more hydroxides than I have hydrogen, and that makes sense with a pH value of 11.3. Okay, so for today's lab, there are still two solutions that somebody, I believe it's two, like coffee and chocolate milk that somebody needs to get out of the fridge. I didn't want to leave it sitting out over the weekend and having it get moldy and nasty. I'm also going to set out some droppers. You need one dropper in each one of the 10 known solutions and then one each for the unknown solution. So 12 droppers altogether. That's why I'm going to set 12 out, probably on station number 2. So as one person please goes and gets the solutions out of the refrigerator, I need somebody else to please go along and tape all the saran wrap off, while a third person goes along and puts a dropper into each one of the solutions. And guys, when y'all are done, leave the solutions inside of these beakers. My next period needs to use these. So you need to clean out your little well plate that y'all are using, but leave the solutions in the beakers. All right, so what y'all are gonna be doing, you'll have 10 knowns, you know the names of these. So do the ones at your table first, and then you can go to another table. So write down what the name of it is. You've got 2 that are unknown, and these unknowns are located on table number 2. So first of all, you're going to put litmus paper in it. Guys, tear these papers in half. You don't need the full strip, so just tear the paper in half. So you're going to put a piece of red and a piece of blue in the solution. If they both stay red, it's an acid. If they both turn blue, it's a base. If the red stays red, the blue stays blue, you know it's neutral. So this is really generic. It just tells you acid, base, or is it neutral? And then you're going to do the p-hydrogen paper. Give me 1 second. Let me get the p-hydrogen paper. Okay, so p-hydrogen paper is a little bit more specific. So p-hydrogen paper has this little scale on the edge of it. It's a rainbow of colors, just like universal indicator would be. And so what you do is, if you can get it out of here, try not to manhandle these because they will take the pH reading off of your fingers. But some of y'all have used strips like this before with your swimming pools. Some of them have done it with all kinds of different things. All right, so tear the strip in half. And like I said, this is my vinegar, so you know it should be acetic acid, so it should be some type of acid pH, acidic pH. And you're going to dip this half in and immediately hold it up and see what the color is. I would say, yeah, it's not quite a 3, it's about a 2 for the pH. And so that's what you're going to write down. So this is a little bit better than just having litmus paper. So p-hydrogen paper, just like universal indicator with the rainbow colors, I can figure out exactly what the pH is to a whole number. Now, if I wanted to do my saliva should be close to a 7. And so if I look at this, we just had an AP review session, so we were just eating food. So it's slightly off. Usually it's a 7. Right now it's slightly acidic as a 6 because I've been drinking a little bit of Dr. Pepper. And so you can have a little bit more specific, but it's still not as good as it should be. Oh, give me 1 second. Let me get the pH meter. Okay, so every station has some of these pH meters. Station number 2, I was going to have some computers set up. If I'm here in the morning, I will try to get them set up, but I don't know if I will be. And so on these little LabQuest, I need you to turn them on right here on the very top. So turn it on, and it's going to take it a second for it to load. And you just hit LabQuest app. Now, there is a sensor right here, and the sensor is a pH sensor. It has some liquid in it. Guys, if you notice, it tells me what the pH of the solution that this sensor is sitting in. If I move it around, it's going to fluctuate a little bit because more of those ions are coming in contact with the sensor. It's actually pretty stable though. But you want to unscrew this from this. So just unscrew it. Now, do me a favor. You want to set this right here off to the side. And then, kind of flick this end off into the sink, rinse it with some distilled water, and then you're going to come along and you're going to put some of this solution right here using the you should have already had some of this vinegar solution into your well plate. You're going to test it with a red and blue litmus paper and then with your p-hydrogen paper. And finally, you're going to set this in here nice and steady and make sure you hold it still, and you should see what the pH reading is. So like if I were to put this right now into this container, my pH values are changing. And if I move it around, it's going to fluctuate it even more. So I'm going to try to hold it as steady as possible, but it tells me what my pH reading is. And then I can flick this off and I can go along and I can rinse this with distilled water in between each of the different solutions just to reset it. And then when you are done, rinse it with distilled water and put it back inside this little container. All right. So this lab You want to get the data collection done. When you are done, all these solutions can go down the drain. Make sure you wash all of these with soap and water, distilled water, put the little strips inside the trash can, and that's it. It's a very fun lab because you have a lot of different color changes that are happening. And then once I have this pH meter reading, like 4.08 right here, if this was my pH reading for whatever solution, I would say, okay, that's an acid because of the pH. And so my negative log of that hydrogen concentration would tell me my H. I could subtract this number right here from 14 to find the pOH, so I could do this value. All right, that is how you do this worksheet. So you have a worksheet, you have a lab. Guys, do not turn in that other page. That's the board work. All right, if you have any questions, I will be back later on in the afternoon, sometime after lunch. All right, y'all have a good day. All right, bye. Y'all have fun.